This video will explain how to classify soil using AASHTO Classification System. There are two flowcharts that we use for this purpose. The one on the left hand side we use it for coarse-grained soil, and the one on the right we use for the fine-grained soil. The boundary between coarse-grained soil and fine-grained soil is the amount of fine, which is equal to 35%. So if we have fines from 0 to 35%, we are going to use this chart on the left hand side, and when we have fines more than 35%, we're going to use flow chart on the right hand side. We'll start typically from the top and go all the way down. In the end, we will need to get one of those symbols, either this one or that one. To classify the soil, we will need to use some important information as the amount of each fraction in soil. And for coarse-grained soil, we need to know soil gradation, while for plastic soil, we need to know plasticity index and liquid limit. Let's see now how we can classify these three soils using the AASHTO flowchart. And in this case, we're going to classify coarse-grained soil. That's why we use this particular flowchart where it says that percentage of fines, it's from 0 to 35. And that's correct. If we look at soil 1, we have fines only 2%. For soil 2, we have fines of 9%. And for soil 3, we have fines of 27% of silt plus 7% of clay will give us still 34%, which is less than 35. That's why we're going to use this particular flow chart. Also, you will see the difference that for soil 1 and soil 2, we are given this coefficient of curvature and coefficient of uniformity, while for soil 3, we don't have it, but we have information about plasticity. Apparently, because there is more fines in this soil, this soil actually became plastic, and that's what we need to know. We need to know liquid limit and plasticity limit to classify the soil. So now let's start with soil 1. What we're going to do next is we're going to start from the top of the chart, and we are going to work out our way to the bottom. So the simple way is to start looking at the amount of gravel and sand and just do comparison. So here we have 26% of gravel, 72% of sand. So we know that we have more sand. That's why we are going all the way to the right, because this box says that sand is dominant compared to gravel. And then next step, again, we need to look at the amount of fines. Again, we'll look at the fines, percentage of it. And we have 2%, which means that we're going to the left box from 0 to 5%. That's correct. And then we know that this soil is sand. We're going to use the symbol S. But still, we can go all the way down. And here we need to decide if the soil is well graded or poorly graded. To do that, we will look at coefficient of curvature and coefficient of uniformity. And we'll look at the criteria for well-graded soils. So if we know that it is sand, for this sand to be well-graded, the coefficient of curvature needs to be in the range from 1 to 3. And yes, the coefficient of curvature given for this soil is 1.05, so it actually fits in the range. And the coefficient of uniformity needs to be more than 6, and we have more than 10, also plus. So this means that this soil, the coefficient of curvature and coefficient of uniformity both meet the criteria for this soil to be a well-graded soil, and that's going to be our answer. And in the end, we're going to write that it's soil well-graded. So S means sand, and W means well-graded. So that's the answer that you need to produce if you work on soil which is similar to soil 1. Okay, now let's move forward and let's look at soil number 2. This soil number 2, it's actually similar in terms of the amount of gravel and sand, but you will notice that it actually has a little bit of more fines. So it has 9% of fines. And it has a slightly different coefficient of curvature and same coefficient of uniformity compared to soil number 1. Okay, let's do this again. So first we start with the comparison, sand and gravel. So we still have more sand, we have 65% versus 26% of gravel. So in this case we're still going to the right because it says there is more sand than gravel. And next we need to decide where we're going to go. And you see that fines is 9%, so we're going to the second box. So this is box. And then we need to go down and we need to decide where to go. And to do that, again, we need to look at the gradation of the soil. So we will look at the amount, we'll look at the coefficient of curvature, and we'll look at the coefficient of uniformity. So you will see that coefficient of curvature is 0.9, which doesn't fall in the range from 1 to 3 for this soil to be well graded, even though the coefficient of uniformity still meets this requirement for coefficient of uniformity, but the coefficient of curvature doesn't. So in this case, the soil cannot be well graded, it should be poorly graded, and we're going to use letter P. So we know that it's sand, and then we need to decide where to go. You will see that we can go both ways. So we still need to know which one is correct. So we know that it is sand and it's poorly graded. So in this case, we can go either to the left or to the right. So we need to find S and P. So that's going to be SP here and SPC here. So this is a kind of special case when we have two answers for the same soil. Both are correct. We don't have more information to determine which one is which. That's why the correct answer for this soil will be both. We can say ASPM or SPC. So this is quite different from soil 1. If there are two answers, you need to write two answers and say either this one or the other one. Now let's look at soil 3, and I will go to next slide where we have the plasticity chart. Let's now classify soil 3. Compared to soil 1 and soil 2, it doesn't have any information on gradation, but we have data about liquid limit and plastic limit of soil. That's why we're going to use plasticity chart to classify the soil. But first of all, we will start with the amount of fines. We know that fines, it's 27 plus 7, altogether 34%. And then, so that's correct. And then we're going to look at the amount of gravel and sand. We see that we have more gravel. So in this case, we're going to go all the way to the left in this box because it says more gravel than sand. And then again, we're going to look at the amount of fines. Percentage of fines is 34, so we're going all the way to the right, this box, and then we're going to go down. So in this case, we can go both ways. We can go to the left or to the right. So many students make mistake. They look what we have more, silt or clay, and then if we have more silt, they will say, okay, let's go to the left. It's going to be very silty gravel. If there is more clay, they will say, okay, it's going to be very clay gravel. That's incorrect. For plastic soil, we decide on the type of soil, if it's silt or clay, only when we look at the plasticity chart. Doesn't matter how much clay or silt we have, it all depends on the plasticity. So now let's look at the plasticity and we will classify this soil. So first of all, we need to get the plasticity index. So plasticity index is liquid limit minus plastic limit. So we have 26 minus 17, sorry, will give us 9%. So now we're going to look at the chart. We first look at liquid limit, and liquid limit is 26. It's somewhere here. And plasticity index is 9, which will give us clay, because this point is above the A line, which is A line. So everything that is above A line is clay. And in this case, according to the plasticity chart, we have clay. So let's write it down, Cl. So you see we have more silt in this soil, but we classify it as clay because we classify it based on its plasticity, not on the amount of silt or clay in the soil. And now what we need to do is we need to find a symbol Cl in here, and that will give us the correct answer for the soil. And we see that Cl is only here, which means that the soil classified as GCl. So this is the correct answer.